You are staring at the 15-minute USD chart. The 9-period and 21-period EMAs cross perfectly. The setup is flawless, but instead of executing, you freeze. By the time you push through that gut feeling of doubt, the price has spiked and you've missed a 40-pip move. For the intermediate manual trader, the market isn't what drains your edge. It is the 200 milliseconds of hesitation between identifying a valid signal and actually clicking buy. The retail trading industry tries to solve this fatigue by selling opaque, prepackaged algorithms. They promise a hands-off approach, but running a blind system without understanding its parameters routinely leads to catastrophic account drawdowns when market conditions shift. The alternative is the hybrid trader framework. You don't abandon your strategy, you translate it into a modular Python tool. You continue to define the high-level macro strategy, while the code executes your edge with cold, mathematical precision. Before writing execution logic, you have to build a stable environment. Trading out of a disorganized script is dangerous, so you start with an industry-standard IDE, like Visual Studio Code, working inside an isolated virtual environment. Your toolkit relies on 3 specific libraries. You use pandas to convert messy price feeds into clean data tables, and a connection library like MetaTrader 5 or CCXT to establish the programmatic handshake with your broker. The third library is Python.env, which secures your API keys. If you hardcode your login credentials directly into a script, you expose your entire account. You lock them away in a hidden environment variable file, completely partitioned from the rest of your system. Structuring your environment this way ensures that an accidental keystroke, a rogue library update, or a public code commit cannot compromise your live market connection. Python doesn't know what a turning trend looks like. It only understands explicit mathematical conditions. You have to translate your subjective strategy into rigid code. You fracture your code into modular functions: data, signals, and execution. This makes your system adaptable. To pivot to a mean reversion strategy, simply swap the signal function. Inside that node, complex logic is distilled to a single Boolean output, false or true. To preserve processing power and avoid false entries from rapid price fluctuations, you instruct the bot to ask that true or false question exclusively at the close of a candle, like the top of the 15-minute hour. By forcing your entry criteria through this mathematical filter, you eliminate the emotional guesswork. The bot follows your proven parameters to the letter, every single time. Generating a valid entry signal is only the first step. If your position sizing is incorrect, or the broker's server rejects your order, that perfect setup becomes a liability. You implement a safety valve framework. Your code dynamically calculates the exact position based on stop-loss distance, guaranteeing you only risk 1% of your equity. For flash crashes, if your account drops 3%, the script executes a hard exit and terminates itself instantly. Every calculation, API response, and executed order is then written directly to a local SQL database or CSV file. This logging system gives you a perfect, time-stamped audit trail of why the bot took a specific action. You can then route those logs through the Telegram bot API. The script pings your phone with trade confirmations and risk metrics in real time, untethering you from the computer monitors. Operating with programmatic risk constraints and real-time monitoring separates a resilient, automated trading business from a reckless script. Before deploying live capital, you have to acknowledge the limits of your historical backtests. They calculate returns using sanitized, perfect data that doesn't reflect actual market conditions. This graph illustrates the execution gap. Perfect backtests don't account for slippage, the physical difference between your requested entry and the actual fill price, or the latency it takes for your data packet to reach the broker. These hidden variables will destroy a high-frequency strategy. To prove your system works, you run your code through a paper trading bridge. By executing the bot on a live simulated account for 14 straight days, you verify that your Python logic actually synchronizes with the physical latency of the exchange. And when macroeconomic events like non-farm payrolls create chaotic, unpredictable spread widening, you step in. You manually pause the engine until the volatility settles. By utilizing this modular Python framework, you remove the click hesitation and emotional fatigue from your daily workflow. You manage the overall process, and the